Hello friends, welcome to my channel. Now let's see part 6 of light chapter. Now question number 1 is, regardless of your distance from a spherical mirror, the reflected image always appears upright or erect. The mirror is, so our correct option is convex. Now let's see our clarification. Convex mirrors, referred to as diverging mirrors, possess a curved reflecting surface that produces away from the light source. They create virtual upright and diminished images regardless of the object's distance from the mirror, with the images being smaller than the actual object. Similarly, a plane mirror also generates a virtual and upright image that is identical in size to the object. So our correct option is convex. Now question number 2. When a beam of light moves through the air and hits the surface of a serene, that is calm pond at an angle, it will, so correct option is, shift towards the perpendicular direction or towards the normal. Now let's see our clarification. This is due to refraction. Okay, this phenomena occurs due to refraction, because refraction is the change in the speed of light as it passes from one medium to another, that is from air to water. The light ray bends towards the normal and imaginary line perpendicular to the surface, resulting in the change of direction. Our question number 3 is, the strength or power of a lens with a focal length of 25 cm in diopters is, so our correct option is 4 diopter. Clarification, let's see our clarification. The power of a lens is expressed as the inverse of its focal length in meters, denoted by the formula D is equal to 1 by F, where D represents the power in diopters and F is the focal length in meters. The focal length of a lens is the distance from the lens to where parallel light rays converge or appear to diverge. Lens power, a measure of its ability to bend light, is the reciprocal of the focal length in meters. So a lens with a focal length of 25 cm has a power of 4 diopters, because D is equal to 1 by F. So here D is equal to 1 by F, that is 25 cm or equal to 0.25 meter. After solving 1 by 0.25 we get 4.0 diopter. So diopter is the unit of measurement for lens power, and a positive power signifies a converging lens while a negative power indicates a diverging lens. The strength of the lens or the power of the lens is directly proportional to its power in diopters. Now question number 4 is, when the magnification of a lens is positive, the image is, so our correct option is virtual and erect 2f. Question number 5. When an object is positioned at the center of curvature of a concave mirror, the distance between the image and the mirror's pole is, so our correct option is equal to 2f. Clarification, let's see our clarification. When an object is positioned at the center of curvature of a concave mirror, the distance between the image and the mirror's pole is twice the focal length, because the image is formed at the center of curvature, which is the same distance from the pole as the object. The focal length of a mirror represents the distance between the focal point where light rays converge and the mirror itself. The center of curvature is the point on the mirror equidistant from all points on its surface. To calculate the distance between the image and the pole, we have the formula 1 by V minus 1 by U is equal to 1 by F, where V is the distance between the image and the pole, U is the distance between the object and the pole, F is the focal length of the mirror. When the object is at the center of curvature, U is twice the focal length, that is U is equal to 2F. Now substitute this value into the formula. We find 1 by V minus 1 by 2F is equal to 1 by F. Solving for V, yields V is equal to 2F. Hence the distance between the image and the pole is indeed twice the focal length of the mirror. Now question number 6. When an object is positioned 30 cm away from a convex mirror with a focal length of 15 cm, the resulting image is, so our correct option is plus 10 cm from the pole. Now let's see our clarification. By using mirror formula, we have 1 by V plus 1 by U is equal to 1 by F. Here U is equal to minus 30 cm, because here convex mirror is used, and F is equal to plus 15 cm. So putting these values in mirror formula, we have V is equal to plus 10 cm. Now question number 7. A concave mirror is employed to project the image of a distant object onto a screen. Okay, measure the distance between dash to determine the focal length of the mirror. So our correct option is the mirror and the screen. Clarification, by measuring this distance, one can effectively determine the focal length, providing valuable information about the mirror's optical properties and its ability to converge light rays. This measurement is essential for understanding and utilizing the mirror's characteristic in various optical applications. Now we have question number 8. The term focal length is applicable to, then our correct option is option number C, for both convex and concave mirrors, because it is a fundamental property associated with the geometry of mirrors. The focal length is defined as the distance between the focal point, the point where parallel rays either converge or appear to diverge, and the mirror surface. For a concave mirror, the focal point is where parallel rays converge after reflecting off the mirror. In the case of a convex mirror, the virtual extension of parallel rays appears to diverge from a point behind the mirror, and this point is also considered the focal point. In both the cases, the focal length is a characteristic parameter that helps describe the behavior of light rays interacting with the mirror, making the term applicable to both convex and concave mirrors. Now we have question number 9. When the magnification of a lens is negative, the image is, when the magnification of a lens is negative, the image is, our correct option is real and inverted. Clarification is, a real image is formed when light rays actually converge at a point in the context of a negative magnification. This implies that the image is formed on the opposite side of the lens, and since it is a real image, it means the light rays converge to form the image. The combination of a negative magnification and the formation of a real image indicates that the image is both real and inverted. We have question number 10. Which of the following factors does not affect the refractive index of a medium? Our correct option is wavelength of light. Now explanation is, the refractive index of a medium is primarily influenced by factors such as temperature, density, and the angle of incidence. However, the wavelength of light does not affect the refractive index. The refractive index is a characteristic property of a medium and remains constant for a specific medium regardless of the wavelength of the incident light. So if you like my channel, then please subscribe my channel.